Alright, so now I have 4 to the power of x is equal to 8. So, to solve this, I'm going to first start by rewriting my 4 here as 2 to the power of 2. So now I have 2 to the power of 2 to the power of x is equal to 8. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x, that's going to equal 2 to the power of 2 times x, which is simply 2 to the power of 2x. So now I have 2 to the power of 2x is equal to 8. Now 8 I can rewrite as 2 to the power of 3. So now I have 2 to the power of 2x is equal to 2 to the power of 3. Now, if you guys already didn't know, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 2x, this is equal to 3. Now to solve this, all I have to do is simply divide both sides by 2. These two cancel out, and I'll be left with x is equal to 3 over 2. So this is one method of solving this problem. Now I actually have a second method of solving this problem. So again, I have 4 to the power of x equals 8. And now I'm actually going to take if I have something in the form a to the power of x is equal to b, then x here is actually equal to log base a of b. And I can actually go ahead and prove this as well. So if I start with 4 to the power of x is equal to 8, can go ahead and take the log on both sides. So I have log 4 to the power of x is equal to log 8. And now if I have something in the form log a to the power of b, I can actually move this exponent of b to the front, so this can equal b times log a. So I can move x to the front, so this would equal x times log 4 is equal to log 8. Now if I divide both sides by log 4, I'll have x is equal to log 8 over log 4, which can be written as log base 4 of 8. So now that I have log base 4 of 8, I'm going to actually instead use this form, so log 8 over log 4. And log 8, that's simply equal to 2 to the power of 3. Log 4, this is equal to 2 to the power of 2. So now, if I move 3 to the front and if I move 2 to the front, I get 3 log 2 over 2 log 2. The log 2's cancel out, and I'll be left with x is equal to 3 over 2. So that's the second method. Alright, so in this problem, I have x to the power of x to the power of 3 is equal to 36. So, to solve this problem, I'm going to start by taking the power of 3 on both sides. So now I'm going to have x to the power of x to the power of 3 to the power of 3 is equal to 36 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is equal to a, this is the same thing as a to the power of n to the power of n. So in this case, I have x to the power of x to the power of 3 to the power of 3, and we can think of x to the power of 3 here as m and 3 as n. So this is the same thing as a to the power of n to the power of n. So I can change the place of these two. So now this is the same thing as x to the power of 3 to the power of x to the power of 3. This is equal to still 36 to the power of 3. Now, 36 I can write as 6 to the power of 2. So now I have x to the power of 3 to the power of x to the power of 3 is equal to 6 to the power of 2 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is also equal to a to the power of m times n. So 6 to the power of 2 to the power of 3, that's going to equal 6 to the power of 2 times 3, which is 6 to the power of 6. So now I have x to the power of 3 to the power of x to the power of 3 is equal to 6 to the power of 6. Now I'm going to let x to the power of 3 equal to the variable y. So now I have y to the power of y is equal to 6 to the power of 6. Now, if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, y is equal to 6. So now I'm going to go ahead and clear up some space. So now I have y equals 6. However, remember that y is also equal to x to the power of 3. So now I have x to the power of 3 is equal to 6. So now to solve this, I'm going to take the cube root on both sides. So now I have the cube root of x to the power of 3 is equal to the cube root of 6. Now the cube root of x to the power of 3 is simply x, so I am left with x is equal to the cube root of 6. So this is my answer. Alright, so in this problem, I have x to the power of 4 minus 16 is equal to 0. So to solve this, I'm going to first rewrite x to the power of 4 as x to the power of 2 times 2. So now I have x to the power of 2 times 2 minus 4 to the power of 2 is equal to 0. I just simply rewrite 16 as 4 to the power of 2. Now, if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So x to the power of 2 times 2, that's going to equal x to the power of 2 to the power of 2. And I have this minus 4 to the power of 2 is equal to 0. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is equal to x to the power of 2, and b is equal to 4. So I have x to the power of 2 plus 4 times x to the power of 2 minus 4 is equal to 0. So now let me clear this up so I can make some more space. So I have x to the power of 2 plus 4 times x to the power of 2 minus 4 is equal to 0. So now this gives me two equations. I have x to the power of 2 plus 4 is equal to 0, and I have x to the power of 2 minus 4 is equal to 0. So, to solve x to the power of 2 plus 4 equals 0, I'm going to first start by subtracting 4 on both sides. So now I have x to the power of 2 is equal to negative 4. So now, to solve this, I'm going to take the square root on both sides. So I have the square root of x squared is equal to the square root of negative 4. Now, the square root of negative 4, that can be written first off, the square root of x squared is simply x, and the square root of negative 4, that can be written as the square root of 4 times the square root of negative 1. So now the square root of 4, that's simply equal to positive or negative 2, and the square root of negative 1 is actually equal to the imaginary number I. So I have x is equal to positive or negative 2i. So these are two solutions. Now for x squared minus 4 equals 0, to solve this, I'm going to simply add 4 on both sides. These two cancel out, and I'll have x squared is equal to 4. Now, if I take the square root on both sides, I have the square root of x squared is equal to the square root of 4. The square root of x squared is x, and the square root of 4 is equal to positive or negative 2. So my four solutions are x is equal to 2, x is equal to negative 2, x is equal to 2i, and x is equal to negative 2i. So this is my four solutions. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 4 to the power of 16 to the power of x is equal to 16 to the power of 2 to the power of x. Now, what I'm first going to do is I'm going to rewrite both of these bases, 4 and 16, as powers of 2. Now, 4, this is equal to 2 squared, and 16, this is equal to 2 to the power of 4. So now I'm going to replace these with 4 and 16. So now we have 2 squared to the power of 16 to the power of x. And now this is equal to 2 to the power of 4 to the power of 2 to the power of x. Now, if we have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of 16 to the power of x, this is going to equal 2 to the power of 2 times 16 to the power of x. Now this is equal to, same thing over here, 2 to the power of 4 times 2 to the power of x. Now, because both of these bases here are the same, this also means that the exponents here are the same as well, meaning 2 times 16 to the power of x is equal to 4 times 2 to the power of x. Now I'm going to replace 16 again with 2 to the power of 4. So now we get 2 times 2 to the power of 4 times x is just simply 2 to the power of 4x is equal to, and now I'm going to replace 4 with 2 squared. So it's equal to 2 squared times 2 to the power of x. Now, 2 is the same thing as 2 to the power of 1. So now if I multiply these two, well, if we're multiplying exponents, let's say we have a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 2 to the power of 1 times 2 to the power of 4x is going to equal 2 to the power of 1 plus 4x. And now this is equal to, on our right hand side, 2 to the power of 2 times 2 to the power of x is equal to 2 to the power of 2 plus x. Now again, because the bases are the same, this also means the exponents are the same. So now we have 1 plus 4x is equal to 2 plus x. Now if we subtract x on both sides, and also subtract 1 on both sides, we get 3x is equal to 1. Now if I divide by 3 on both sides, these two cancel out, and I get x is equal to 1 over 3. So this is our answer.